Ladies and gentlemen, previously tutor, and join me in this video as I explain the graphs of the equations of motion in physics, and we're going to look at two types of graphs, that is the velocity time graph and the distance time graph. All right, so let us start with the velocity. Start with the velocity time graph. So we are going to start with the velocity time graphs. Now, as we do this, I just want you to pay particular attention to the shape and to the shape of each graph that we are going to draw here, because it's quite important that you know the shape. Okay. Now, a velocity time graph, it's a type of graph where velocity is plotted against time. All right, and under this graph, we are saying is velocity versus what? Time. And the area, all right, the area below the curve, right? So below, let's not the curve, below the graph, let's say under the area under the graph, all right, measures what? It measures the distance traveled. It measures the distance traveled. Okay, we're together, right? So now, how is now there? We are going to look at three types of velocity time graphs. All right. The first one is plotted as follows. So I'm going to plot it together here with you. Okay. Like that. And this one just goes like that. And well, just like that. Then like that. Okay, so here we've got velocity in meters per second, and here we've got time in seconds. This velocity time graph is what we call uniform velocity time graph. So this one shows uniform velocity. C9. So this one is for uniform what? Velocity. Is it clear? Let's look at graph number 2. So graph number 2, we are still under the velocity time graph. So it is like this. Okay. We're drawing together, right? You've seen how the graph is? So we have got velocity in meters per second. As usual, we've got time in seconds. All right. This graph shows uniform acceleration. Okay, so this graph is showing you uniform acceleration because there is a uniform change in acceleration. And the last one under the velocity time graph, graph number 3. This one is like this. It's like this. Have you seen the way it is? Then we have got, of course, the area under the curve. This one, okay, shows you non-uniform acceleration. This is non-uniform acceleration. I hope we are following each other. And if you're enjoying the video, please don't forget to subscribe. Follow me on TikTok and Facebook. You can also start your online classes with us, and we'll be able to explain concepts for you. All right, so that is under the velocity time graph. Now let's look at distance time graphs. Okay, we call it B. Since the first one was B, was A, so we call it the distance time graphs. All right, so this is under our distance. We are saying this is distance versus time. That means distance is plotted against time, and the distance time graph, the same way we had the area under the graph showing us total distance covered under this velocity time graph. Even here we have the area under the graph. The area under the graph, or let me not say the area, let me say the slope or the gradient. So the slope or the gradient, it represents the velocity. All right, represents velocity. That is what the slope and the gradient or the gradient represents under a distance time graph. And here I'm going just to give you two graphs, which I hope there will be enough. The first graph is of this nature. Again, if you find this video helpful, please share. Also leave us like, subscribe, and do us a favor by starting your classes with us online. Quite affordable and very much effective. So this one, just say it goes like that. All right, so this is where we have distance here plotted against time, because distance is in meters and time in seconds. So once you obtain a line where distance and time, they are giving you a straight line passing through the origin, this is showing uniform velocity. Remember we said the gradient, this is a gradient or the slope, it shows you representing what? Velocity. So this means this line in the middle is showing you the velocity. This is for uniform velocity. Have you seen the difference between distance and time graph? Under velocity time graph, our uniform velocity, well, there's a line like this. But now we have a line passing through the middle. You should be able to differentiate between the two. Alright, so that is uniform velocity. Graph number 2. Let's do this. So graph number 2, under the distance time graph, well, I want it to be like this, and I hope you... Okay, so there we go. And there. Okay, so let's say the graph is like this. Sorry, it's like this. I want it to go like that. Are we together, right? Now take note. Once you have, this is distance in meters, let's say, because in meters, and this is time in seconds. This means once you have a graph like this, you'll be forced to pick any point from the graph there, and what do? You draw the tangent. You draw the tangent, and then you find the gradient, which we know that is just the change in distance and over the change over the change in time. So we have the change here in distance and over the change in time. Now we know that the change in distance and the change in time is just what? Velocity. But this velocity is not uniform. It is non-uniform. So this one tells you that the velocity we're dealing with is non-uniform velocity. Like that. We have explained the basic graphs of motion using and I hope that these 5 graphs, they have made a difference in your life, and they have also changed the perspective of you about these equations, and I hope they really helped you. Now leave us a subscription, please. I'll keep on mentioning that, and like and share. Invite others to this channel or to my Facebook page or to my TikTok. I really appreciate. Moreover, your online classes are in our hands, safe and sound. You can start anytime. We'll be there to help you. Very affordable. When I say very affordable, I mean it.